So we have our kite there. So like I said, the top two sides are equal, the bottom two sides are equal, but not all four. We're going to talk about other things in the kite. One thing, I want to list some properties. You guys notice I already listed the first one. Like I said, do me a favor, copy the figure. We're going to add a couple more things. We're going to talk about the diagonals. The diagonals, if you notice, are my dotted lines inside. So we're going to talk about the diagonals as well. So kite is two pairs of adjacent and congruent segments. Remember, the word adjacent means next to, and congruent means same size, same shape. So obviously two sides that are adjacent, so next to each other, so two pairs of adjacent and congruent segments. That's just basically to say the top two are the same, the bottom two are the same. That's basically what that is saying. Property number two, let's add the angles at the sides are congruent. So the angles at the sides are congruent. There's only two sides. So let me see if I can write with this. What I mean with that is this angle, if I show, it's like angle B, the entire angle B and the entire angle D, they're congruent. So not all four angles, it's only angle B, but I'm talking about the entire corner. Notice how my diagonal cuts angle B in two different angles? So I'm talking about the entire corner B and the entire corner D, they're congruent. Not working. Alright, another thing we're going to write is a diagonal that connects the side angles bisected by the other diagonal. So only the diagonal that connects angle B and angle D, only that diagonal is bisected by the other diagonal. Remember, bisected means cut in half. So if the whole diagonal BD, let's say it's 10, just to say a number, is going to get cut down into 5 and 5. Only that diagonal. The one that goes up and down, the diagonal AC, that is not. Now the diagonal AC is different. I can see the top side is way smaller than the bottom side. So only the side so the diagonal that connects the side angles, so see there's two sides, the diagonal that connects the side angles gets bisected by the other diagonal. So once again, only that diagonal is bisected. It's cut in half. There's going to be a total of 5 properties. Another thing we're going to learn is that diagonals are perpendicular. You guys remember what perpendicular means?
Yeah.
What's perpendicular?
Intersect.
Intersect at
90 degrees.
90 degrees. So the diagonals are perpendicular, which means they intersect at 90 degrees. And one thing we're going to learn also, notice how my two diagonals, they create 4 triangles. We know that the angle in the center, where the diagonals intersect, that's 90. So if I give you one part of an angle, you should be able to find everything else, because you should know that the three angles of a triangle add up to 180, so on and so forth. So like I said, so that's important, that the diagonals are perpendicular. It is not that the perpendicular part, it's just that it gives us another angle, and it gives us triangle. Okay, we're going to use that idea later on. And then fifth property is the diagonal bisects the angles on top and bottom. So only the top and bottom angle are bisected. So if my angle C, the entire angle C was 40 degrees, then it will be cut down into 20/20. Only the top and the bottom angle get bisected. The side angles do not. so just to have an idea, like I said, if angle C, like I said, it was any number, I said 40 degrees, just any number, four corner C, the diagonal cuts it in half. Remember, that happens only on the bottom and the top angle, not the sides. Only top and bottom. And as we should expect is, the four angles, the entire corner A, B, C, and D, the four corners of the kite, they should add up to 360. Because it's a four-sided figure, remember we use the formula n minus 2 times 180, there's four sides. So let's each, the four angles, all the four should add up to 360. Once again, from the formula n minus 2 times 180. Any questions on kites? Can I take this off?
Yes.
Okay. Trapezoids are a little bit easier to work with. Trapezoids, they look like this. Do me a favor, copy the picture of your trapezoid, and then we'll talk about the properties of it. So I'll give you time to copy the figure. And I think with trapezoid we talked most of it. Properties that our trapezoids have, I know we talked about this, is one pair of parallel sides. Right? We know that top and bottom are going to be parallel, so we're going to call those bases. A base is something you can stand on. We can stand it on the long base, which is standing on, but if we flipped it 180 degrees, we can also stand it on the small base. Not the sides, because it will flip, it will fall. So, like I said, the two sides that are parallel, we're going to call those bases. The two that are not parallel, so the sides, we're going to call those legs. So, trapezoids have two bases and two legs. The bases are going to be very, very important for areas. We're going to be looking at areas of these figures in quarter 3. So when we come back from Christmas break, a little after, we'll look into areas. So areas will be very, very important for the bases. Bases will be very important for the area. So another thing that we have is the two angles at each side add up to 180 degrees. Let me see if I can take the little thing from there. There we go. The two angles at each side add up to 180 degrees. So what that means, if I have the trapezoid standing as it is, if I was to look at the two angles on the left, right, the top and the bottom angles, then they add up to 180 degrees. I could have the top 100, the bottom 80, right, because they add up to 180 degrees. I could have the top 50, the bottom 130, because they add up to 180 degrees. If I look on the right, the same thing. Top and bottom have to add up to 180. And not all trapezoids have the same numbers on the right and the same numbers on the left. Not all of them. And they will have it only if we call them isosceles. If we call them isosceles, then the two angles on the right are the same as the two angles on the left. But only they're isosceles. So for them to be isosceles, the two legs, so the two sides at the side, they're congruent. So that's what's called isosceles. There's a few other things that happens with their isosceles. So we're going to come and say, if isosceles, so if the two sides of the side are the same, so if isosceles, the legs are the same. Right? That's basically what makes it isosceles. So if they're isosceles, the legs are the same. There's going to be three properties we're going to have if they're isosceles. Remember, they're being isosceles if the legs are the same. Another property we have is if isosceles, the base angles are the same. So if isosceles, the base angles are the same. I'll explain that in a minute. if isosceles, the base angles are the same. Remember how back in the days with isosceles triangles, when we stood it on the two legs that were the same, the two angles of the bottom were the same? We call them base angles. So the same thing here. If we have the isosceles bending, the two angles at the bottom are going to be the same. So if one corner, the entire corner is 80, the other corner has to be 80 as well. Only if it's isosceles. Right? If it's not isosceles, they don't have to. But if it is isosceles, the two angles of the bottom have to be the same. And the interesting part is the two angles on the top are also the same. Because remember I told you guys the top and the bottom were both bases? So since the top is a base, the two angles on the top are also base angles. So not all four are the same, but the two on the top are the same, and the two on the bottom are the same. Only if it's isosceles. And we're going to be dealing with a lot of isosceles triangles today. Another thing that we have is, if isosceles, the diagonals are congruent. You guys see my diagonals? So do me a favor, write that thing down. If isosceles, the diagonals are congruent. So the length of each diagonal is the same. They don't cut each other in half. They're not perpendicular. Like they cross in any degrees that they want. Like I said, they don't cut each other in half. They're just the same length. If the legs are the same. So if isosceles, the diagonals are congruent. So the length of the entire diagonal is the same. Only if they're isosceles. Like I said, the angle or cutting each other in half doesn't happen. The only thing is that the length of the diagonal is the same. Can I take this off? Not yet. So kites have more interesting things than the trapezoid. Even though we do have triangles in the trapezoid, 4 triangles, you cannot really use them much. And as we expect, the 4 angles of the trapezoid, the 4 corners, they should add up to 360 as well. Right, so it's a 4-sided figure, n minus 2 times 180, 360. Alright, can I take this off? Okay. Let's take a look at our worksheet. Our worksheet looks like this. For the first 4 questions, I'm asking you guys to find x and y, and I'm giving you some perimeters. Like in question number 1, I mentioned the word perimeter. We know perimeter is the distance around the whole thing. Let me increase this a little. So the perimeter is 116. I know this is 28. Forgot my y. Sorry, forgot the y. This is 28. How big is this other side for right now? We don't know, but do we have another side that is the same length?
Yeah.
So x, well, let's call it x. Well, actually, I cancel out the y from question 3. My bad. So we have that, and I know that if I add everything, 28 plus 28 plus x plus x, notice how I'm adding the 4 sides? That's my perimeter, and I know my perimeter is 116. I'm not going to finish it off, but I'm pretty sure from here you guys can solve for x. Yeah. So you guys solve for x, and you guys plug it in. And that's the answer for question number 1. Now, I'm not going to quite finish it, but we added the 4 sides. It's just that one side we needed to write 28, and another side we needed to write an x. Add everything and equals to 116. From your figures, problem number 3 is the one that looks a little fancy. And the reason why is because it's a kite on top of a trapezoid. So it's 2 shapes that you guys do know. For you to solve for x, solve the trapezoid, the kite first. This angle right here, do we know how big is this angle? know. It starts with a 1.
182.
No.
137.
137. Because remember, the two side angles are congruent. So if we do stand it, that is 137. For me to solve for x, I'm going to go 137 plus 137, because I'm adding the two side angles, plus 22 plus x. You notice I'm adding the four angles of the kite. 137 plus 137 plus 22 plus x equals what? How much is that before x? What is it? 360. Right, because in a four-sided figure, n minus 2 times 180, the four angles add up to 360. So you guys can solve for x. For you guys to solve for y, I'm just going to help you guys, and I'm going to say this angle at the bottom is 137. And the reason why, because you notice how the top and the bottom I mark them the same way? A little one slash from the angle. So that's just to tell you guys that they're measured the same way. So that corner is 137. That will help you to solve for y. Any questions for the first four? Actually, for the first six. No, it's only four, right? Oh, six. Any questions for the first six? No. One thing I'm gonna give you guys though, if on so my trapezoid on P, if I was to cut down over here again, I'm gonna call this side 4, just because this side over here is 4. So I'm going to say that side is 4, and this bottom side in between my dotted lines is 4x plus 1. So I'm just making this part at the bottom as big as the other. And then it has two sides, 4 and 4. That will help you guys with your perimeter.
And isn't this side 2 also equal to 2x minus 3?
This side right here, good. This side right here is 2x minus 3 because it's an isosceles triangle. I see the two slashes on each side. So just to help you guys a little, the bottom base, the whole bottom base is 4x plus 9. Right, because it's a 4x plus 1 plus the 4 on each side. So the whole bottom base is 4x plus 9. The whole thing. All the way from P to Q. The whole thing is 4x plus 9. Right? Okay. Once again, you guys can finish the rest. Looking at this, the last 8 questions, I didn't number them, but like, you notice how there's 4 on each row. So the first 4 says find the measure indicated. So I'm given that this thing right here, from M to the center is 5 meters, from the center to the bottom is 10. So I see from the center to L is 5. I'm going to say this other side right here should also be 5. Right, because on a kite, because I'm dealing with kites there, on a kite, the diagonal that connects the sides is bisects. So I know that side is 5. So here, one of my questions is, how big is KM? 15. Alright, so we're going to write 15 meters. How big is LN? 10. So that's it. My focus on those 4 questions is, do you remember that side gets bisected? Right, not the long one, just the one that connects the sides. Some of them I wrote the 2 measurements, like you guys see on that one. I wrote 10 and 10. But in some others, I did not. It's just to see if you guys do remember that it gets bisected. Now, on the last 4, I have trapezoids, and then some of them are rotated. So find the perimeter of each trapezoid, perimeter only, at the sides only. I'm going to talk about I'm going to include the number on the inside, but for the perimeter, I don't need. For perimeter, you only need the sides. So that 8 centimeters is not needed. And so we're going to use it. That we call it the height of the trapezoid. We're going to use it for area. Right? So area is this third quarter. So we'll come back to quadrilaterals, but that's not so late. For perimeter, just add the 4 sides. So you got what? 42? 42 centimeters. And this is not a isosceles trapezoid, right? Because if you notice one side is 15, the other side is 12. So this one was not, some of them are. Alright, any questions? Tomorrow we'll look at parallelograms, and we're going to look a little more detail on the diagonals. Remember, before we talk about angles, we look at the diagonals, but we'll also talk about angles tomorrow. And then our quiz this week is Thursday. I think I told you guys last week already, right? Did I? No? All right. The quiz this week, we're going to push it to Thursday instead of Friday, because the test next week, I'm going to push it to Wednesday. And then the reason why I shorten it each week by 1 day, this week and next week I shorten each by 1 day, is because I want, on Thursday of next week, I want to start reviewing for the final. The final, everything. We have a total of 90 questions on the final. So I don't want just the Monday and Tuesday of finals week, the Monday and Tuesday. I think those 2 days only is too little. Right? I needed more days. So that's why the quiz today is Thursday. I mean, this week is Thursday. The test next week is Wednesday. So that way on Thursday of next week, we start reviewing for the final. Like I said, that way we review. I'll review every single question on the final. Every question.